Okay, so I just realized when I was finishing up, and I just realized that I never recorded anything. It's just that's the way it's been. That's why I'm retiring. So I'm just going to go through. I'll go through everything, an abbreviated version of it. Okay, what we talked about, and I'll just cut to the chase on everything, so it's fast. That's the good news for you. No yapping. Let me share the screen. Okay. What? Okay. We're all recording now. All right, so here we go. Yes, I'm just gonna say yes, no, yes, no. You know, this is on there. Hey, boy, sure does take up a lot of room. But that is, like during the meeting, I said this is on there. This is a definite because, but now I'm looking at it and knowing how much is coming. I only got 2 pages. Let's put it this way. If I were to take one out, this would be the first to go, only because we've talked about it. It's super important, but we have talked about it. I don't know. I think I'll probably kill something else first, but that's probably on there. It probably is still on there. Okay. We went ahead and we had a discussion on this, and finally, or I'm talking to myself. We have a quote discussion, but there were some comments. And I decided just to drop this one. It's a great question, but there's another one kind of like it, so we'll drop that one. Number 2, don't worry about it. Number 3, although it's would be easy for you and it'd be easy, I could squeeze it in. I just don't think there's enough room. So we're going to say no to 3. Not a hard problem, but I'll definitely say no to 4 because multiple choice. You know, I don't like multiple choice or true false on tests that much. And then the 5 is a definite yes. That is a definite yes. 5 is even more likely than number 1. Okay, on the test. Oh, we forgot about 6. 6 we said no. Multiple choice conceptual questions, probably no. Well, not probably, this is no. 7, explanation, it's important, but no, it wouldn't make it on the test. Just because I don't have a lot of time, for one thing, to grade. I've only got 2 days to grade this whole thing, so explanations take forever to grade, really slow. So good news for you, I guess. Number 8, it's too specific. I mean, it's not really a big idea. It's, yeah, okay, how submarines work, buoyancy, blah, blah, blah. Number 9 ended up being a check mark. We said we didn't know. First I said, I don't know. It might not, but it won out over number 2. I think it's more straightforward and it still brings in the 2 angles and all. So that's a yes. First you got to do, now you can't really helping hurting. I mean, that is what you're doing. This is not really a pulley system. So 10 is great and important, but I don't think we have time on the test and the room it takes to put that on there. So imagine that, well, if I say it's a no, it's a no. 11, man, I didn't want that to be a no. But it just got to be so much with work and power that I just couldn't afford the space for this one, I don't think. But I'm going to have to say no because I said no. So that I had it checked off and now I'm saying no. Okay. Number 12 is a no. Yeah, I mean, you can just write in your notebook. Derivations with open note tests really don't make much sense. Although people don't write in their notebook, then you're burning them, but you're really testing something else there, preparing this. 13B is a no, but 13A is a yes, because you can easily fit that in there. In this case, the elevator was rising. Maybe the elevator is falling on the test. Probably most likely what I would do. 14's a no. Curvature of space-time is interesting, but really officially this is not a modern physics class. This is a mechanics class. 15's a yes, double yes for sure. But what I told them was it'll be a planet or a moon in our solar system somewhere, like Triton or Europa or some crazy one like Phobos, you know, some little one. Number 16. Yeah, 16 is a yes, because it's visual. It shows restoring force. It shows it's basically the spring dance, you know, showing the force pointing towards the inside, getting smaller as you get to equilibrium. As the spring gets happier, spring gets angry the further away you stretch it or compress it. So that's a yes. 17 is a no. I do have that one worked out on the reference sheets, which I will show you tomorrow. 18 was a yes, but then I kind of thought I'm not going to have room because of all the stuff that came after this. So that's a no now. 19 is definite yes. There'll be one like it. I told them that you watch out because I might like give you, you know, because I can add a little 10% surprise, 30 points worth of surprise. I might like give you the mu sub k, and then you got to solve for n, because I just gave you the friction. But what if I didn't? What if I told you the mu sub k if I'm feeling naughty when I write it, and then you have to go through and find, okay, well, n is mg cosine 15. The other little naughty thing I might do, maybe I have somebody pulling, but when they're pulling on it, they're pulling at an angle. Okay, I don't know. It's just eventually get the point where you need to not keep adding stuff. So I'm probably good with 19 the way it is, although it is open notebook. So I don't like people just copying on the notebook. Copying. Here's how you work this problem. I have no idea what I'm doing. Here's an algorithm. Blah, 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 blah. So you throw a little twist in there to see if they really know what they're doing. You know, because otherwise somebody just looks at this and goes, okay, I know to subtract the FK, so do exactly what in the notebook. Okay, so it won't be going down the incline. I'm probably going up the incline. That's enough to fool somebody that doesn't know what's going on. I'm not trying to punish you. My job is to find out if you know what's happening. 20 is a definite 100% yes. You'll see it. Doing the works of all the different forces and then summing up all the work. Remember that normal force is always 0 for work unless you're in an elevator. E is summing them all up. It'll look the same as this problem, just different numbers. We went in detail about why this works on 21. That's the bad thing about me not recording it, was we spent a good 10 minutes on FOIL. You can look at it over here. Whenever you're doing FOIL, I mean, that is what dot products are. You're dotting the two together. Well, I can dot them like I do in algebra, right? First, outer, inner, last. But the outer and the inner will always cancel because I dot j and j dot I are always going to be 0 because j is perpendicular, j is vertical, I is horizontal. The angle is always 90, cosine of 90 is 0, so it doesn't matter. So really FOIL becomes just FLA, because they'll just first and last. And so that's why we can get away with stacking and stacking them and then multiplying together. I dot I becomes 1, j dot j becomes 1, and we get 4 Newton meters. I talked about even a sailboat, the path is not the same thing as a displacement. Displacement's where you start and where you end, and it's a vector. Paths are not necessarily vectors. So if you're in a sailboat, you can't say your path was displacement, because I suppose you could tack and that kind of thing, but most likely if you're just in a simple sailboat, you're going up, you're heading in, you already have initial velocity, you're heading in this direction right here, the wind is blowing on you, a consistent wind, say out of the northwest. This is a map view, but then your path comes up and comes back around, but your displacement only cares about where you started, where you ended. Okay, and then really you go, well, I don't care. I just want to know how much energy that wind poured into my system, being my sailboat. And that's the dot product works beautifully there. So 4 Newton meters was poured into our solo cup, right? Now we could go back and include, now here's something we didn't talk about. If you include friction, the path does matter. Friction is like Pac-Man, and friction constantly eats the little dots. No matter where it goes, it's always eating dots. And that's, so friction path does matter. Okay, but in this case, with displacement path doesn't matter. But that's something we wouldn't have time to get into. 22 is a yes. I might ask you on something like that. What's your thoughts on initial conditions? You know, here there had to be moving. There had to be some kinetic energy to begin with. 23, I said, well, this, and I marked it out. I'm sorry. I thought I was done looking at it, but so ignore the mark out. That one will not, that's a no. That is a no. But I think it's the hardest problem we've worked all year. It didn't help that I didn't give a force for pull. Let's say that the mice combined can pull with 4 newtons of force only. And then you say, well, they lose the battle because the daggone thing's still sliding down the ramp. They're trying to pull it up. And so you end up with one unknown. That's the final velocity. But I don't want to waste your time. This is not on there. And then finally, we looked at 25, and I had it as a question mark. And now that I killed so many other ones, I'm going to make that a check. That's a yes for that one. It's brand new, I realize. We'll talk about it more tomorrow on one of the worksheets. Okay. So tomorrow we'll go through and put all your stamps in there, and we'll make sure that you've worked the problems that you're supposed to work. We'll spend a lot of time on that one. We'll talk about power, but we'll spend a lot of time on the work. So I think it's 612. I think it is. Working problems 4 through 10, I think. We'll go through them pretty quickly. But I think one of them, and then we'll go to another worksheet. Yeah, we got our work cut out for us tomorrow. It's not shortened, though. There's no advisories, so good. Yeah. Okay, that's it. Well, that was an abbreviated version. Okay. I will put this on YouTube as soon as I can. So thank you for being a lovely audience. And stop recording. Boom.